So hey there, today we are going to be discussing on the bitwise operators in Java. So there are quite a lot of tutorials available on this, but because I created the other bitwise videos, so I thought it might be a good idea to make this one as well. So you can find the basic definition in tutorial point and the basic documentation as well. But let us see what do we actually mean by it. So we have three types of bitwise operator: and, or, and XOR. In Java we have these three. Okay, and these bitwise basically mean that we are working with the bits, right? That is quite self-explanatory, that bitwise operators work on bits. And as I told, we have three types: and, or, and XOR. So let's deep dive into the and operator. Okay, so you might have studied the and operator in Java, this one, right? This is used for comparison. I mean adding the conditions, right? So let's say x is greater than 10 and y is greater than 20, right? So this goes inside a if block, right? And then we have some executions to do. So basically what this and does is, if basically this evaluates to true, right, then it will check this also. And if this also evaluates to true, only then we'll be executing this. But if this is false, then it will not check the second one as well, and it will not execute this as well. And in the last case, if the first one is true but the second one is false, that would also result in not executing the function, right? I mean the if block, it would not run it. So if we create a chart, basically 0 1 chart for it, so we can say that for and, if we have 0 and 1, we would be getting 0. If we have 1 0, we would still be getting 0. A 0 0 would still be a 0. Only a 1 and 1 would be a 1, right? So that is our case. So in case the first one only evaluates to false, it makes no sense to check the second one, right? So it does not check the second one, so it completely skips this whole part, second part, this part. Okay, so that is what the and operator does. Now let us see what the bitwise and does, right? So let's see the bitwise and. So in bitwise and, we simply use one uh, symbol only. Earlier we were using two symbols, right? Two ands, but in bitwise we only use one of them. So let's take the same equation from above, right? So we had if x is greater than 10 and y is greater than 20. So what the and here does, so we basically had one and, so now this is a bitwise and. Okay, so now what it does is, it will check if this is true or false. It does not matter, it will still check the second one as well, if it is true or false. If both of them are true, only then it will execute this code block, but it will evaluate both these statements in any case, right? So this will be executed and this will also be executed. This might be optional. If both are true, only then it will run the body. Meanwhile in the and operator, we were basically not checking the second one completely if the first one was false, but it is not the case in bitwise and. In bitwise and, we anyway check these two, right? We anyway execute these two, but the code block is then dependent upon the both. So this chart is basically applicable here as well. So basically if both are true, only then we are going to execute this body right here. Okay, but the conditions, both conditions are going to be checked here. Okay, so that is one use case of the bitwise and. right? So that is one of them, right? And as I had mentioned here, so one use case is using it in complex conditions and the other is with numbers. So what do I mean when I say with numbers is, let's say we have 9 and let's say we have 4 for instance, okay, and we are using the AND, bitwise AND here. So let us convert them to binary. So 9 will be 1001 and 4 will be 1 0 0 0 1 0 0, right? So what the AND will do is, let's write them here, 0 0. So only if both of them are true, only then it will be a 1, otherwise it will be a 0. So it is complete 0 in our case. So 9 and 4 should be 0, right? And we'll put it to test as well. So I'll comment this code for you. Let's say we want to do 9 and the AND operator with and 4. So let's run it real fast, and we can see that we get the 0 as expected. So that is what the bitwise AND does. Okay, so these were the two use cases of the bitwise AND. So we can use them in conditions and we can use them with numbers. The next case is bitwise OR. So these are all bitwise AND. So let's see bitwise OR now. Before bitwise OR, I'll like to slightly touch on the basic OR operator, right? So OR operator, we have basically two bars, right, like this, and it is also used in complex uh, conditions. So similar to above, x is smaller than 10 or y is greater than 20, right? So this also is a if block, and then again we have some body here. So what will happen is, if any of them is true, then this block will be executed, right? If x is greater than 10, if this is false, so we will skip to this condition and check if this is true. Otherwise, if this one is true, if the first condition is true, we need not check the second one because we only need one of them to be true, and that should be good enough. So if this is true, this would not be executed and this will be executed. But if both of them are false, so the body will also be not executed. If both of them are true, then the body will be executed. So the basic table for the OR would look like this. So if we have 0 1, it would be a 1, 1 0 would also be a 1, 1 1 would also be a 1. However, only 0 0 would be 0. So either of them should be 1. That is the case. But if the first one is true, if the first condition is true, we never check the second one, right? So that is the scene. Similar to the AND one, if first one is false, we never check the second one because we need both of them to be true. Similarly in OR, we only need one of them to be true. So if the first one is true, we don't check the second one at all. So now let's look into the bitwise OR, right? So bitwise OR. Bitwise OR also similar to bitwise AND is used in two scenarios. One is in complex conditions, like the conditions we represented above, and one along with numbers, right? So first we'll be checking this complex condition one. So let's take this example only. So if x is greater than 0, smaller than 0, smaller than 10, or y is greater than 20. So now in this case, it will check if this is true or false. It does not matter. It will still check the second one if it is true or false. And if either of them are truth or true, it would run this. If both of them are also true, then also it will run the body, and if either of them is true, then also it will run the body. So the table will look similar to this one. It's just that the both conditions will be executed, like these conditions, first this one and second this one, both will be checked. So that is the difference between bitwise OR and the normal OR, right? And now let's check how it is used with numbers. So with numbers, we took 9 and 4 above. We'll take the same example. So 9 and 4. So 9 is represented as 1001. 4 is represented as 0101, 0100, right? So basically, according to what table we created above, we will simply say that 1 will be taken here. It will be 011. So this is what we should get. So this will basically be 8 plus 4 plus 1. So that should give us 13, right? Let's put it to test right away. So let me open the IntelliJ IDEA and let's change it to a bar now. Right. So let's put it to test. And we did get 13, so that is what we're expecting. That's good. Now finally we will be seeing the bitwise OR operator. So basically it is also called XOR, but let's say, so it is basically used only with numbers. Okay, used only with numbers, not in conditions or something. It is only used with numbers. So let's say 9, and the symbol is let me mention the symbol first. Symbol is this one, the up arrow, right? So let us see how we use it with numbers. So let's say 9 and this OR operator and 4, right? So let me convert it to binary. So 9 is 1001 and 4 would be 10 100, right? So this is our 4 and this is our 9. So if we write them side by side, 0100, now the conditions here would be basically if we create a table for you, we can see that if we have a 0 1, let me put all the conditions first. So if we have a 0 and 1, only then it will be 1. If we have 1 and 0, then also it will be 1. If we have the same like 1 and 1, it will be 0, and if it is 0 and 0, still it will be 0. So same things will return in 0, and if we have different things like 0 1 or 1 0, that would be 1. Okay, so let's see what we get here. So this would be 1 0 1 1, which would basically be 8 plus 4 plus 1, which would basically be 13, right? So let's see if we get the same thing by running it here. So let's run 9 with 4. Give me a moment. 9 and 4, right? So that is what we want to check, and we do get 13, so that is what we expected, right? So it is similar to the bitwise OR answer. So let's take another number now. Okay, so that we get a different number this time. Let's take a different number, and let's say we take 14 and let's say 8, right? So 14 will be 8, then 4 12, and that would be, wait, let me do it, 2 to the power 1, 2 to the power 2, 2 to the power 3. So 1 1 1 0, right? So that would be our 14. 8 would be 1 0 0 0, right? That would be our 8. So let's write them down. 1 1 1 0. So 0 0 would be 0, 1 0 would be 1, 1 0 would be 1, and 1 is also 0, right? Note this here, that 0 0 is 0 and 1 1 is 1, 0. Same things written 0, right? Note these. Okay, so this is what we got, and this should basically 6, right? 4 plus 2. So let's put this to test as well. 14 and 8. So 14 and 8, right? So let's run it real fast, and we get 6, and that is what we expected, right? So that seems pretty much good to me. So yeah, I hope that the bitwise OR operator is also clear as well. So let's recap it real quick. So firstly, we discussed that there are three types of bitwise operators: the bitwise AND, OR, and XOR, right? Then we looked that bitwise AND can be used with conditions and with numbers as well, right? After that, we looked at the normal AND operator, right? So we looked at how it simply checks one of the conditions first, the first condition. If the first one is true, only then it will check the next one. And we also checked the chart for it. So basically, this was the case where it returns 1 and it executes the body basically. Otherwise, if the first one is false, it does not check the second one in that case, right? But the bitwise AND, what the bitwise AND does is, even if the first one is true or either it is false as well, it will still check the second condition, right? The body will run or not, that is still dependent on the upper table if both are true, but it will check the both conditions. It will run the both conditions in any case, even if it is true or even if it is false, right? Then we also looked at how to use the bitwise AND operator with numbers. So basically, as the AND does, so basically we saw how AND works, right? So we looked at how it would work with numbers. So basically 1 and 0 would be 0, 0 and 1 would also be 0. Only when we get a 1 and 1, only then it would be 1. So we also saw an example of it, right? Then we looked at the OR operator, basic OR operator. So we looked at how if the first one is true, it does not check the second one, right? Because it only needs 1 to be true in order to be executed. And we saw that here, that only if both of them are false, only then we do not execute the body, right? Then we check the bitwise OR operator, which is also like similar to and used with complex conditions along with numbers as well, right? So what the bitwise OR does is, it will check the first condition if it is true or false, and in either case it will check the second condition as well, right? The running or not running of the body will all similarly depend on the table above, but it will check both conditions either way, right? So that is the difference between the bitwise OR and the normal OR operator, right? So also we checked how to use the bitwise OR with numbers, and we also ran it on the IntelliJ IDEA as well. Lastly, we saw the bitwise OR operator, so it is only used with numbers, and this is the symbol used with it, right? So it is not similar to either of them, but what it does is, only if the numbers are not same, that is if 0 1 or 1 and 0 are coming, only then it will be true, right? So as you can see here, I've shown that, right? And we also saw an example with that, and we also checked the example on IntelliJ and it seems to be coming fine. So yeah, that is it about the bitwise operators. Now to use it in different algorithms and problems, that is definitely a different topic to be covered on. But yeah, that is about this video, and hope you liked it. Peace.